In this video, we're going to talk about probability distribution tables. Let's recall that a discrete random variable is a variable whose values can be listed. When we list the values of a random variable in a table along with their probabilities, we will get a probability distribution table. Let's take a look at how it works. So here we have an example. We have an event Y. Y is an outcome of experiment of rolling a 6-sided die, and we're going to list all possible outcomes and their corresponding probabilities in a table. So basically, here's my table for the variable Y, and we're going to list the sample space, right, for the rolling of a 6-sided die. So since it's a 6-sided die, we could roll a 1, a 2, a 3, a 4, a 5, or a 6. Now, what's the probability of each of these events? Well, as we already know from chapter 4, the probability is 1 out of 6 for each one. So we have in one column, we have all the values of the variable listed. And in the second column, we have all the corresponding probabilities listed. This is what we call a probability distribution tables. Okay, they don't have to be vertical, they could be horizontal, where the first row would be your variable Y, and your second row will be probability of that variable. So either way. Okay, let's take a look at the next example. It says, consider flipping a fair coin with 0 assigned to heads and 1 to tails. V is the outcome of an experiment. Create the probability distribution table of V. So let's do a horizontal one. Our event V, possible outcomes or sample space, either heads or tails. So either 0 or 1. So those are the possible values. What is the probability of each value? Well, if it's a fair coin, then the probability of each outcome would be 1/2 or 0.5. So there we go. This is our probability table for flipping a coin. Let's take a look at this example. It says, let U be the number of heads out of 3 tosses of a fair coin. Construct a probability distribution table for V. Again, I'm feeling like doing a horizontal table. So let's list all possible outcomes. And I encourage you to stop here and to think about it and list all the possible values and then verify that you were right. And we're going to continue. Again, we have 3 tosses of fair coin, and we are counting the number of heads. So what are the possibilities? We could have 0 heads, 1 out of 3, 2 out of 3, or 3 out of 3. So that's those are our values for possible values for variable V. Now, what are the probabilities of V? Okay, so we know already that the number of outcomes for 3 tosses would be 8, right? And so in how many ways do we have 0 heads? Well, it's only one way out of 8, right? So it's 1 out of 8. What about 1 head? So it could happen at 1, 2, 3 out of 8. And then 2 heads, also 3 out of 8. And 3 heads is 1 out of 8. Okay, so interesting property of the distribution table. So since we're listing all the sample space, so basically all possible outcomes, it makes sense if the sum of the probabilities will equal to 1. So we cover 100% of probabilities, right? 100% of outcomes. Let's check if that's true. So we have 1/8 plus 3/8 plus 3/8 plus 1/8. What do we get? We get 8 out of 8, which equals 1. So this is the property of a probability table. If you're looking at the true probability table, then V lists all possible values of the variable, and probabilities of those outcomes should add up to 1 or 100%. And the last example in this video says, let W be the number of heads out of 2 tosses of an unfair coin for which the tails are twice as likely as heads. Construct the probability distribution table for W. So first of all, let's describe the possible outcomes for one toss. We could have heads, or we could have tails, right? We say that tails are twice as likely as heads. So tails could appear 2/3. The probability of tails is 2/3. The probability of heads would be 1/3. It's either heads or tails will appear in one toss of a coin. So together they form 100%, right? 1/3 plus 2/3, but the tails are twice as likely. All right, now we're tossing our coin 2 times. Okay, so we could have 0 heads, 1 or 2 heads in 2 tosses. So these are our possible number of possible values for our random variable. Now we need to figure out the probabilities for each one of those outcomes. Okay, so let's list all the outcomes first. So these are our possible outcomes. In case of 0 heads, we get tails and tails. What's the probability of that? Well, again, remember that's 2 events, 2 selections. Applying our fundamental counting rule, we're going to have 2/3 multiplied by 2/3. That gives us 4/9. Okay, then tail followed by a head. So that would be 2/3 multiplied by 1/3. That's going to be 2 out of 9. And then same thing, 1/3 times 2/3. That's 2 out of 9. And then both heads would be 1/3 multiplied by 1/3 would be 1 out of 9. So the probability of 0 heads would be both tails, 4/9. Probability of 1 head, it's either this or that. And remember, for or, we're going to add the probabilities. So it's going to be 4/9 again. And probability of 2 heads, we have 1 out of 9. So it can happen only one way. And the probability of that is 1 out of 9. Now, to check yourself, do these probabilities add up to 1? And the answer is yes. 4/9 plus 4/9 plus 1/9 is going to be 9 divided by 9, which is 1. So yes, we're looking at a probability distribution. We can turn a frequency distribution into a probability distribution by dividing each frequency by the total. And that will give us a relative frequency, which, as we talked before, actually is your probability, right? So here we have a frequency distribution that summarizes the data collected and organized into this table. So basically our first column, our random variable X represents the number of pets a student has. So here our frequency, here's the number of pets, and here's the frequency. So we see that, for example, 4 people had 1 pet, only 1 person had 8 pets, so forth. So what's the total frequency? In other words, how many people were asked about pets? Well, if we add all the frequencies, the total will come out to 15. So what's the relative frequency for 1 pet? So in this case, that's going to be the probability that a randomly selected person will have 1 pet. Well, that's going to be 1 out of 15. For 2 pets, that's going to be 3 out of 15. For 3 pets, that's 2 out of 15. And then for 4 pets, it's 1 out of 15, and so forth. And here we have a probability distribution of the number of pets. Now we can use this table to predict what's the probability that the next person we ask is going to have 1 pet or 2 pets or 3 pets, so forth.